Hi guys, ladies, gentlemen, team, etc. My name is Jim St. Ledger. I'm from Intel, and I'm just going to kick this event off today. Thank you first and foremost for coming out to our campus. The weather seems to be cooperating. We came down from Oregon yesterday in the rain, so it's a welcome relief for all of us. A little bit of myself. Myself and actually the rest of the Intel crew all work in Intel's data center group and a subsection of that called the Network Platform Group, or NPG, because we at Intel do speak acronyms. So if you guys run into one today like DPDK, and I think I have the world's record for saying that at speed, DPDK, please stop us and let us know, and we'll see if we can define it. If you're following us online and you see an acronym, feel free to tweet a question to us, and we'll stop and define that for you as well. My day job is software product marketing, so I'm not the smartest guy in the house, but I brought along three of my smartest friends that I'll introduce in a minute here, or they will introduce themselves as we go. What I wanted to do is set up a little bit of what we're going to talk about today. And for me, the best analogy is what might be some of your morning commute or evening commute: traffic congestion. In this case, it's cars. In our case, it's network infrastructure. And this is a problem that's only getting worse. Right? It's getting worse because of policies like BYOD that your CIO may be implementing to make the employees happy, but if you're working in IT or the network side of the world, it makes a disaster both from a device security perspective, traffic congestion, etc. Things like Facebook and Pokemon Go just driving traffic like crazy through your network. So what are you going to do about this? Because at the same time, I'm reasonably sure they haven't ramped up your asset and CapEx budget as much as your traffic's ramped up. So today we're going to talk about some ways that you can tackle this problem in a hopefully reasonable manner. There's a couple trends in the industry that we're deeply involved in. How many of you are familiar with SDNNFE? Show of hands. Almost anybody, almost everybody, a few folks not. So software-defined networking and network functions virtualization. This is really the concept of taking away the standard boxes you see on the left here, which are fixed function, can only do one task, and they do it extremely well, to moving to flexible standard high-volume server designs where you can run these type of workloads and functions in virtual machines. What that does for you is lets you have flexibility in your network, makes you significantly more agile to be able to deploy and move around these workloads and capabilities, and also lets you quickly provision the same box to do different things. So I'm sure you guys are familiar with peak traffic load and off-peak traffic load. Well, if you have to buy a dedicated box for every one of those capabilities and peak traffic load, then they sit idle many other times. When you can move those into virtual machines, all of a sudden you can use the same type of hardware to do a variety of tasks. And you can use those during downtimes to do other tasks, whether it's network backup or search algorithms or whatever, depending on the nature of your business. So this is getting a tremendous amount of traction in the industry. SDN is kind of leading the way in the data center and cloud. Network functions virtualization, or NFV, is leading the way in the telco infrastructure. And as both of those collide together, you'll see all of those used at the same time. To make this work, though, you really need to first and foremost have a standard high-volume server as your basic box building block platform that has this capability and function in it. And those of you who've been using Intel architecture servers for years might think back to say, well, yeah, it runs a web server great, but it's not doing routing and switching, and it's certainly not what I use for my firewall. So there's a lot of work that's been needed to be done over the years to go and fix that. And that's what we've been working on now at Intel for probably 8-10 years plus in some cases. In this model I'm showing you here, we call this 4-to-1 workload consolidation. And it sort of starts from the top. The top is just your basic applications. This is what I call the bread and butter of the apps you guys run in your data centers, in your cloud, in your network. And then it works down to control plane algorithms. And for us, it was a lot of work we started probably 10, 15 years ago of porting those algorithms, many of which were dedicated to run on specific SOCs and dedicated boxes. We ported those algorithms to run on Intel architecture, often in a Linux environment, and now they run extremely well into there. The third one gets into the data plane, or the packet processing area of the network. And this is really where a lot of the focus we'll have for today's conversation start. Tom mentioned DPDK, or Data Plane Development Kit. That's fundamental to enabling our capability in there. And that's really about how do you move packets at a very high rate, efficiently and effectively on Intel architecture. For large packets, enterprises have done this for years. In the telecom infrastructure area, when you're moving a lot of mixed packet sizes and a lot of 64-byte minimum size packets, it's a whole different ballgame. That's where your biggest problems get into, and Keith actually is going to start us out later with some analysis of that. So we've made a lot of progress on that page. The last one in the 4-to-1 workload is signal processing. This is really signal processing, media processing. This is sort of the next frontier that we've started tackling probably 5 to 8 years, past years we've been working on. There's a media SDK that's out there taking over some of what are historically DSP functions. And there's a lot of people in the industry today that I clearly can't name, but next time you're at a trade show, people doing media processing, go ask them what's inside their box and you may be surprised by the answer. We're not going to spend a lot of time talking about that today, but we'll leave that for a future session with you guys. From a standpoint now of, well, how do you go from the concepts of NFE and SDN and implementing things like 4-to-1 workload consolidation and go and deliver it to an industry? And this is where a lot of the standards works comes in and our technology leadership activities. I'm not going to rattle off a bunch of the things, but hopefully if you look at the top left, you'll see some of these open source projects. You'll be familiar with at least a few of them. Intel has involvement in every one of these. From having a half dozen software engineers working on these projects to having dozens of engineers working on these projects across the board. Some of them are basic building block activities like Linux, for example, or Open vSwitch, for example. Some of those are pulling them together into a platform, setting standards like IETF, et cetera. There's an awful lot of collaboration in the industry, which is what sets the trend. One person's not going to pave the path that everyone else is going to follow. So there's an awful lot of standards writing, specification writing, and consolidation in the industry of the path forward. It's happened with the creation of virtual machines, as we've decided, hey, we're going to use Zen, KVM, VMware, Hyper-V, et cetera. And it's happening in many other spaces in network infrastructure as well. And the last one is an ecosystem. And our ecosystem in this space is called Intel Network Builders. It's a collection of, I think we're almost up to 200 members today. And these are really the bread and butter of people that are supplying the hardware, the software, and the system integration, and some of the service providers around the globe for telecom, datacom infrastructure. You can guys go do a search on Intel Network Builders, and you can take a quick glimpse of who these people are. It's run-rated names that you'll all know very, very well. So all these together really helping us deliver how you'll bring this network transformation from the old world of fixed function boxes to the new world of flexible virtualized functions. The goal of what we're going to walk through today is really to go from the traffic congestion we saw on the first slide to the Autobahn you see on this slide. Our talks today are really trying to use this analogy of how you speed your traffic up, but also do it in a more flexible manner. I didn't want to use the Yugo to Porsche analogy, but perhaps it's overlaying that on top of an Autobahn infrastructure thing. So today you're going to hear 3 talks that are going to talk about that. The first one is going to be Keith Wiles talking about the network Autobahn. His talk is going to focus on how you can increase the throughput of your traffic in the network. And yes, he is going to, Tom had a great guess, he is going to talk about the data plane development kit. After that, Brian Will is going to talk about network zero to secure. So after what I'll loosely call the Snowden effect, encryption and security has taken at least an order of magnitude of attention across everybody, including IT infrastructure folks to even end user consumers who are like, hey, so is WhatsApp secure and are people monitoring my texts and everything else? So security and infrastructure security is top of mind. Brian's an expert in this field and we'll talk about that. And some acceleration technology of how you can add security to your network but have it not bog it down completely. And then lastly, Edwin Verplank is going to come in and talk about network HOV. This is really how do you take all these concepts we talked about and add other elements of performance optimization to them. There's some new technologies called Intel Resource Director Technology, or RDT, he's going to walk you through, as well as a few other things, and really bring it together for a close right at the end.